$11 billion. That's what America just spent on a single warship. The USS John F. Kennedy, CVN-79, represents the cutting edge of naval technology, yet viral photos show rust streaks covering its hull before it even left the shipyard. Critics are calling it a national embarrassment. The Navy claims it's the future of American sea power. After more than a decade of construction and billions over budget, the Kennedy is finally approaching delivery. But the real question isn't when it will sail, it's whether this massive gamble on revolutionary technology will work when missiles start flying. Today we're revealing the truth about America's newest supercarrier, the secret weapon systems that make it different from anything afloat, and why China's naval expansion makes this single ship more important than you ever imagined. The crisis that forced change. To understand why the Kennedy exists, you need to understand what was wrong with the ships it's replacing. By the late 1990s, America's Nimitz-class carriers, the backbone of naval power for decades, were hitting hard limits that no amount of upgrades could fix. These weren't ships falling apart from age. They were ships designed with 1960s assumptions, facing 21st century warfare. The first crisis was electrical power. Nimitz-class reactors generated around 60 to 80 megawatts, enough for propulsion and basic systems, but nowhere near enough for modern warfare. Future weapons like lasers require massive energy output. Advanced radars need continuous power. Electronic warfare systems demand even more. The electrical margin was essentially gone, meaning these carriers couldn't adapt to emerging threats. The second problem was manpower. Each Nimitz-class carrier needs over 5,000 sailors just to operate. That's 5,000 salaries, 5,000 benefits, 5,000 training programs, costs that multiply over a 50-year service life into billions of dollars per ship. Recruiting was getting harder as civilian tech jobs offered better pay for similar skills. The third bottleneck was launch systems. Steam catapults, the same technology used since World War II, stressed modern aircraft frames, required constant maintenance, and couldn't handle lightweight drones. Every launch cycle damaged sensitive avionics and limited operational flexibility. The fourth limitation was weapons handling. Cable-driven elevators moved ammunition from magazines to the flight deck painfully slowly, capping combat sortie rates at around 120 launches per day. In sustained combat, that's not nearly enough. The math was brutal. By the 2020s, these carriers would need replacement. Building more Nimitz-class ships would cost over $100 billion and still carry the same fundamental flaws. The Navy faced a choice: build obsolete ships or gamble everything on revolutionary technology. They chose revolution. The Ford-class program was born, and the USS John F. Kennedy would become its proving ground. The $13 billion disaster that came first. Before the Kennedy could be built, the Navy had to construct the first Ford-class carrier, USS Gerald R. Ford CVN-78. It became one of the most expensive disasters in military procurement history. The Navy contracted Ford in 2008 for an estimated $10.5 billion. It was commissioned in 2017 at $13.3 billion, a 27% cost overrun that made Congress furious. But the real problems weren't financial, they were technical. The Electromagnetic Aircraft Launch System, or EMALS, was supposed to revolutionize carrier operations. Instead, it became a nightmare. The Navy required 4,166 launches between failures. Ford averaged about 400, barely 10% of the standard. Jets sat grounded while technicians desperately tried fixing the catapults. The Advanced Arresting Gear, AAG, fared no better. This electromagnetic landing system also fell drastically short of reliability goals, creating dangerous situations for pilots attempting to land on a pitching deck at 150 miles per hour. Perhaps worst of all were the weapons elevators. The Navy required all 11 electromagnetic elevators to be operational at commissioning. Instead, most remained non-functional for years. Several weren't fixed until 2021. 4 years after the ship was supposedly combat ready. Moving ammunition from storage to aircraft became a structural crisis that crippled the entire carrier. Congressional hearings turned vicious. Some lawmakers called Ford a $13 billion boondoggle and pushed to cancel the entire Ford-class program. Defense analysts questioned whether the Navy had bet too heavily on unproven technology, but cancellation was impossible because construction had already begun on CVN-79, the USS John F. Kennedy. The critical question became, would Kennedy repeat Ford's catastrophic failures or prove the technology actually works? Revolutionary power, the twin nuclear hearts. Deep inside Kennedy's hull, hidden from cameras and critics, sit two Bechtel A-1B nuclear reactors. These aren't just propulsion plants, they're the foundation of everything that makes this carrier different. While Nimitz-class reactors produce 60 to 80 megawatts, the A-1B units generate roughly 250 megawatts, 3 times as much electrical power. This surplus energy transforms what the carrier can do. Kennedy can simultaneously operate EMALS catapults, AAG landing systems, high-speed weapons elevators, and the Enterprise air surveillance radar without straining the power grid. But the real game-changer is what comes next. That massive electrical margin prepares the ship for weapons that don't even exist yet. Future directed energy weapons, lasers capable of intercepting missiles at the speed of light, require megawatts of continuous power. Electromagnetic railguns that fire projectiles at hypersonic speeds need enormous energy bursts. Advanced drone control systems, managing swarms of autonomous aircraft, demand computing power and connectivity that older ships can't support. The A-1B reactors are designed for 50-year operational life without refueling. That means Kennedy can serve until the 2070s while continuously integrating new technologies as they're developed. The Navy isn't just building a carrier for today's fights. They're creating a platform that can adapt to threats and weapon systems that won't exist for decades. This design philosophy of building in massive excess capacity is either brilliant future-proofing or wasteful over-engineering. Time will tell which. EMALS, the catapult that defies physics. For 6 decades, aircraft carriers used one method to launch jets: high-pressure steam pushing a massive piston forward with brutal force. The system worked, sending 40-ton fighters from 0 to 165 miles per hour in under 2 seconds. But it was violent, inflexible, and increasingly obsolete. Steam catapults stressed airframes, shortened aircraft service life, and required endless maintenance. Seals, valves, and pipes constantly failed in the harsh saltwater environment. Worse, steam offered almost no fine control. The launch force couldn't be precisely adjusted for different aircraft weights, creating safety risks with every deck cycle. EMALS, the electromagnetic aircraft launch system, was designed to eliminate every one of those problems. Using linear induction motors, EMALS accelerates aircraft with controlled electromagnetic energy. Power can be precisely tuned for each launch, making it versatile enough to handle everything from 10,000-pound drones to 60,000-pound fighters. The benefits are extraordinary. EMALS offers 30% smoother acceleration, dramatically reducing airframe stress and extending aircraft service life. It boosts sortie generation by roughly 25% by launching aircraft faster with less downtime between cycles. But there's one massive problem. On USS Ford, EMALS suffered catastrophic failure rates. The system that was supposed to revolutionize carrier operations became its biggest liability. Now Kennedy must prove the technology actually works, because if EMALS fails again, the entire Ford-class program's credibility collapses completely. The electromagnetic web, AAG, and advanced weapons elevators. Launching aircraft is only half the challenge. Catching 40-ton fighters landing at 150 miles per hour and stopping them in just 300 feet without crashing into the ocean is the other. For decades, carriers used hydraulic cables, 4 steel wires stretched across the deck that grabbed a jet's tailhook and forced a violent stop. The old system had critical limitations. Cables wore out rapidly under repeated impacts. Hydraulics struggled with different aircraft weights, potentially damaging light drones while risking overruns with heavy fighters. The system lacked adaptability for future unmanned aircraft. Advanced Arresting Gear, AAG, replaces hydraulics with electromagnetic absorbers using linear motors. Sensors instantly read incoming aircraft weight, allowing smoother deceleration that protects both airframes and pilots. AAG supports everything from small drones to heavy strike fighters while requiring significantly less maintenance than cable systems. Combined with emails, Kennedy should theoretically launch and recover over 160 sorties daily, with surge capacity reaching 270 during combat operations. That's a massive improvement over Nimitz carrier's 120 sortie limit. Kennedy's 11 electromagnetic weapons elevators lift heavy ordnance rapidly, cutting rearming time nearly in half. Lessons from Ford's troubled installation led to better manufacturing, tougher testing, and smoother integration. Kennedy's elevators are expected to be fully operational at delivery, directly addressing one of Ford's most embarrassing failures: the rust controversy and construction reality. In 2024, photos of Kennedy went viral showing reddish-brown rust streaks covering the hull. Critics pounced immediately, calling it proof of massive construction failures. How could an $11 billion warship be rusting before ever leaving the dock? The answer is less dramatic than it appears. Naval architects confirm this is surface oxidation, completely normal during construction and fitting out. When steel sits exposed to salt air before final protective coatings are applied, surface rust develops. It doesn't affect structural integrity and gets addressed during final preparation. The same thing happened with Ford. Rusty streaks appeared in photos, but after testing, she deployed successfully in 2022. Advanced systems like EMALS and electromagnetic elevators require extensive testing and certification before the Navy will risk putting sailors aboard. Each system must prove it works, not just in controlled tests, but under operational conditions. Delays are frustrating, and optics matter. To the public, a rust-covered ship looks like failure. To the Navy, it's the painful but necessary process of getting a complex vessel right before it carries America's sons and daughters into combat. The China factor. Why Kennedy matters now. While Kennedy waited at the pier, China kept building carriers at an alarming pace. In 2000, China activated its first carrier, Liaoning. By 2019, it launched Shandong, its first domestically built carrier. In 2022, Fujian arrived with electromagnetic launch technology similar to Kennedy's emails. By 2025, China began constructing a fourth carrier. This matters for American security in specific scenarios. Consider a conflict over Taiwan. If China attacks, American carriers become critical for any military response. China's carriers would attempt blocking U.S. forces, and numbers would determine who controls the waters. The South China Sea adds more tension. China claims these waters as sovereign territory, while American carriers conduct freedom of navigation operations to keep international shipping lanes open. The math is worrying. America has 11 carriers, but they're spread globally. In a Pacific fight, only 2 or 3 might be immediately available. China could concentrate all its carriers in one theater. Kennedy helps close this gap. It doesn't just replace old ships, it maintains American naval superiority in the Pacific at a time when China's rapidly building capability to challenge that dominance. The USS John F. Kennedy CVN-79 represents either the Navy's boldest gamble or its biggest mistake. After 13 years of construction and $11.3 billion spent, this 100,000-ton floating fortress is finally approaching delivery. With electromagnetic catapults, advanced arresting gear, revolutionary weapons elevators, and enough nuclear power to run a small city, Kennedy embodies the future of American naval warfare. But Ford's early failures cast long shadows. If Kennedy's systems work as promised, it validates the entire Ford-class program and secures America's carrier dominance for decades. If they fail, it raises existential questions about whether the Navy bet too heavily on unproven technology. As China rapidly expands its carrier fleet, Kennedy's success or failure will help determine who controls the Pacific, and with it, the future of global power. The world is watching to see if this $11 billion bet pays off.